Alright guys, so we're going to continue our study of radical expressions. We're going to do multiplying and dividing in this section, and then we'll do adding and subtracting. Alright, so some important notes. Notice that we can multiply them if their index, the number that's right here, is the exact same. So like the cubed root of 3 and the cubed root of 9, we can multiply them together because they're in the same jail. So think of it like if we had the cubed root of 3 and the square root of 9, they can't talk. Like one's in county jail, one's in state jail. I don't know, this is how much I know about like prison. And the jail is different than prison. So they can't talk. All right, it's got to be the exact same index, and then they can multiply together inside. All right. So if they don't have the same, then they can't multiply together. And then after you do it, then we can find like the cubed root or the square root or the fourth root or whatever it is. So it's going to have the same index, same tiny number up front. So both of these are square roots, so they can do it. So the square root of 15. 15 doesn't simplify at all, so he's done. 21, square root of 21 and square root of x, they're both square roots. That was kind of funky. And we can't simplify that, so it's also done. Okay, 18 and 2. 18 times 2, I'm like nearly positive, is 36. Z5 and Z, that's like an invisible one right there, so it's really Z6. So let's do square root of 36, square root of Z6. So square root of 36 is 6. And then remember the exponents, there's an invisible 2 right there. So we're going to do 6 from there, divided by 2 from there. So that's really Z to the third. So I'm going to combine him and him together, so I get 6 Z to the third. This is my final answer. All right, both of these are cubed, so 15 times 5 times 3 is 15, and then x times x squared is really x cubed, and then y, there's no y over here, so he'll stay and hang out. All right, so cubed root of 15, cubed root of x cubed, cubed root of y. So the cubes are 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. All right, 15 happens right here. But 15 can't divide by 8, so he stays. Okay, we're going to do that 3 divided by that 3, and I get 1, so it's just regular x. And then this can't simplify anymore, so it's just cubed root of y. So everything that's on the outside stays on the outside. Everything that's on the inside stays on the inside, 15y. So it's x times the cubed root of 15y. All right, let's do this one. So both of those are fourth roots. So I'm going to do 125 times 5. I get 625. W 6 and 2, that makes 8 because you really add the exponents when you multiply, and then you just multiply the coefficients. So the fourth roots are 1 times 1 times 1 times 1, 2 times 2 times 2 times 2, 3 times 3 times 3 times 3, 4 times 4 times 4 times 4, 5 times 5 times 5 times 5, and I end up with 625. So I can stop there. All right, so I'm going to do 4th root of 625, 4th root of W8. All right, so the 4th root of 625, it's 1, 2, 3, 4, 5. And then I'm going to do 8 divided by 4. I get 2, so it's really W squared. And both of those are outside, so it's 5W squared is our answer to simplify that craziness. All right, so that was the multiplication rule. Now we have the quotient rule. Same thing. If these right here, these indexes aren't the same and they can't talk. And remember, like the fourth root is the same as like whatever it is, so the 1 over 4. Alright, so this is the same as square root of x over square root of 49. We know the square root of 49, 7. So we're done there. Can't simplify square root of x. Okay, here, I'm going to do cubed root of negative 125, cubed root of y to the 7, cubed root x to the 6. All right, cubed root. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5. So I get 125, but it's negative, so it's negative 5. And y to the 7th, so I'm going to do 7 divided by that 3. I get 2, remainder 1. So it's really y squared with 1 inside. I can't leave it like that. I need the cubed root. And then I'm going to do 6 divided by 3 is 2. So it's x squared. Everything that's on the outside goes together. And everything on the inside goes together. So negative 5 y squared. We need ABC order. X. Uh-oh. Oh my gosh. This guy is in the bottom. Terrible. Silly me. Okay, so y squared, little tiny 3y over x squared. He's on the bottom. Don't get confused. So easy. All right, let's do this guy. So first, let me write it as one big thing. 32r11 over 8r7. And here's why I wrote it as one big thing, is because it's both square roots and they both have the same letter. Over here, it was already written as one big thing, but also these were different letters, so I couldn't simplify that. But I can right here, because 32 divided by 8 is 4, and 11 minus 7 is also 4. So I just have to simplify that. So square root of 4 is 2, and square root of r to the 4, we're going to do 4 divided by 2 is 2, so I get r squared. So this is really 2r squared. Is what 4r to the 4th square root of 4r to the 4th is, which was the simplification of that guy. So if you just like break it up into little tiny pieces as you're going, it originally looks like super scary, but it's not. All right, so here's a big rule in math. You cannot have a radical or imaginary, well, imaginary numbers are also called complex numbers, in the denominator. Right, I just don't know how many times I can say this. It's a gigantic rule. Okay, you cannot have a radical or an imaginary or complex number in the denominator. So like right here, square root of 5, you can't have it. So you have to rationalize the denominator so that there's no square root. And you would do the same thing if there was an I. So we'd go through the same process. All right, so right now I don't want you to simplify it. All I want you to do is figure out the conjugate. All right, so the conjugate is basically, what could I multiply the top and the bottom by so there's no more square root? Okay, and right here, so to get rid of that square root, I'm going to multiply by square root of 2. Now when I multiply by square root of 2, I'm not going to simplify, I'm just going to tell you why I'm choosing square root of 2. Square root of 2 times square root of 2 is square root of 4, which is 2. So it gets rid of that square root. Over here, this is really square root x. Square root 7x, square root 3y. I'm going to multiply this guy by square root 3y on the top and bottom. And square root of 2 over 2 is 1, even though it's kind of crazy complicated. Square root 3y over square root 3y is also 1. And I can multiply anything by 1, and so get this out. All right, so square root 3y times square root 3y is square root 9y squared. Square root of 9 is 3. Square root 9y squared is y, so I get 3y. So look, I picked itself. Okay, I picked itself. Square root 4 is 2 square root x. So this, we can rewrite him as 3 square root 6 over 2 square root x. So I'm not going to multiply the top and the bottom by square root 4x. I mean, I can. There'll just be some more simplifying later. I'm going to multiply the top and the bottom by square root x because I don't want to get rid of the 2 necessarily. I need to get rid of the square root. And so when I do that, I get square root x squared, which is really x. All right, let's look at some numbers. So all I did here was I multiplied by whatever was in the radical, okay? So the square root x was in the radical here, the square root 3y was in the radical here, the square root 2 was in the radical there. Let's look at these. So these guys, the conjugate, is I'm going to keep the bottom and just change the sign. Keep bottom, change sign. And I'm not going to explain it right this minute why that works, but I am going to when I actually work out these problems. All right, so when I multiply these guys, I'm going to do square root of 2 plus 4 on the top and the bottom. So I just kept what it was and changed the sign. Here, I'm going to do 3 minus square root n on the top and the bottom. Right here, I'm going to do 5 plus 2i on the square root of bottom, top and the bottom. All right, remember, x minus 5 times x plus 5. Just remember this for a minute. And we get x squared plus 5x minus 5x minus 25. These guys cancel and you get x squared minus 25. And the middles go away. And this is the same thing except one's plus and one's minus. These are considered conjugates because the middles end up going away and you just have the last two terms. And so that's kind of what's going to happen here when we end up multiplying these out is the middle terms are going to go away. And so you will no longer have the I and you will no longer have the square root. You'll just have regular numbers or like an X or an M, and it will simplify. All right, so the denominator cannot have a radical or a complex number, and so we have to rationalize it. And the reason it works is because, like I said before, any number over itself, whatever, 9 over 9, the letter CTX over CTX, whatever it is over itself is always 1. And so what we're really multiplying here is by 1. And so we're just kind of like changing it. Like I'm the same person, whether I'm me or 50 pounds lighter, 50 pounds heavier. It's just simplifying, expanding, or deflating like a fraction, except it's a complicated fraction. All right, so let's do this guy. So we're going to multiply the top and the bottom by square root 23. And when I do that, I get 43 square root 23. I can't do anything with that. Square root 23 times square root 23 is just 23. And 43 and 23 don't cancel, so that's your answer. For real. Yeah, for real. Okay, and I'm gonna, that problem takes like 5 minutes or 4 minutes or something, so I'm gonna pause on this, and in the next video, I'll do the next thing.